Okay, kiddies, we're going to be doing questions 13 through 18 of the June 2015 Regents in this video. Let's get it going. So question number 13 over here, it says quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove that ABCD is a parallelogram? So what we should probably start off by doing is, one, figuring out what level this is from, and that's level 5, parallelograms. And then let's write out those 5 properties we know about parallelograms that might come in handy in this question. All right, so our 5 properties are props of parallelograms is 1, opposite sides are parallel. 2, opposite sides are congruent. 3, opposite angles are congruent. All right, 4, consecutive angles are supplementary. And then finally we have our last one, 5, diagonals bisect each other. Hold on one second, my pasta's boiling over. Like 6 property, it's like the special one that I like to write out, which is if you have one pair of opposite sides that are parallel and congruent, then you know it's a parallelogram, right? Then it's a parallelogram. So these are our 6 properties that should come to your head. Now, what we're going to do here is actually just sketch this out, right? We should take a look at this parallelogram, ABCD, and that will help us go through this problem. Now, if you look here, we kind of just want to figure out which ones are properties, right? Because we're trying to figure out which ones isn't, so we should figure out first which ones do prove it's a parallelogram. The first one is out. AC and BD bisect each other. That's diagonals bisect each other, so that one is out. It then tells us that AB and CD are congruent. BC and AD are congruent. That one's out because that's opposite sides are congruent. And then we're down to our final 2, right? And what we're looking for here is number 6. One pair of opposite sides that are parallel and congruent. And that would be number 3, because that's telling us that AB and CD are congruent and AB and CD are parallel. So that's one pair of opposite sides that are parallel and congruent. This one is out. And so we're left with number 4. And that's telling us AB and CD are congruent, and then a different pair of sides are parallel, and that doesn't prove it's a parallelogram. So answer number 4. Number 14, this is a circles question, right? The equation of a circle is x squared plus y squared plus 6y equals 7, or the coordinates of the center and the length of the radius in the circle. So we know this is a level 9 question where we learned about circles. All right. If you ever want to review this lesson, by the way, this is a 9.6 lesson. And what we do here is we just first, you should remind yourself that the general formula, the standard equation of a circle is x minus h squared plus y minus k squared is equal to r squared. All right, and we want to get our equation here in this form. So we have x squared plus y squared plus 6y is equal to 7. Now, since our number is already on the other side of the equation, we're just going to start completing the square here. Now, x doesn't have a partner, but y does. So we have y squared and 6y. So we're going to do 1 completing the square over here. And we're going to add it to both sides, because if you have one thing to this side, one side of the equation, you have to add it to the other. So if you remember this, you got to take your 6 divided by 2 and square it. So 6 divided by 2 is 3. We square that 3 and we get 9. So we're going to add that to both sides. Now x squared comes down. We're going to factor this, and this factors to x plus 3, right? It's just this number, squared equals 16. So our center and radius are as follows. Our center is, well, x has nothing, so it's 0, and we switch the sign here, negative 3. And this, since r squared is equal to 16, we take the square root of 16, and we get 4. All right, and that is answer number 2. Nicely done, guys. Nicely done. All right, number 15. Triangles ABC and DEF are drawn below if AB is 9, BC is 15, DE is 6 and EF is 10, and we know that B is congruent to E. Which of the statements is true? All right, and it gives us all these kind of different statements. Now I'll tell you this. The first one says that A is congruent to E. All right, and that one can be knocked out. That's like kind of the silly one because A, we know E is congruent to B already. We're not going to use that one. Next thing is we see that triangle ABC is similar to DEF. And I would ask myself this, can I prove that these two triangles are similar? And I'm going to go for it. So this is a level 3 question. It's about similarity. And you might remember there's 3 ways to prove similarity. And those 3 ways to prove similarity, it's 1, angle, angle, 2, side, 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 and 3, side, angle, side. And those are only 3 ways to do it. Now remember, to prove it, now you just have to see if the ratios are the same, right? If you're looking for the sides. So let's set up some ratios. First, I'm going to check out CB is to FE. This is the larger side on both of these. All right, so that's 15 over 10. And that's going to give me 3 halves. Or you can put that in the calculator and get 1.5. My next one is AB to ED. And that's 9 is to 6. And once again, that reduces to 3 halves, or that's also 1.5. Then we also have one congruent angle. We know that angle B is congruent to angle E. And what we have here, by showing all this information, this would be considered our evidence, is side angle side similarity. So this just goes to say that number 3 is right. We've proven they're similar. So it's 3. No further work needed. These are out. Number 16, this is a classic. If triangle ABC is dilated by a scale factor of 3, which statement is true of the image of A prime, C, B prime, and C prime? Okay, we've said this a bunch of times. This is from level 1. This is transformations. And what we know about dilations, there's a lot of facts about dilations that should come up in your brain. One of these dilations facts, oh man, hold on. Transformations. Let's write down some things we know about dilations. 1, facts about dilations. Well, one thing I know is this. When you dilate a line, the image is parallel to the preimage. So we always know the image is parallel to the preimage, right? Any line is. Now, 2, I know angle measures are preserved. And since angle measures are preserved, I can knock out 2 of these answers. And that would be 3 and 4. Because these are basically telling me that when you dilate the triangle, the measure of angle A is 3 times the measure of A prime, which that says that, like, no, the angle got 3 times smaller. No, that makes no sense. And this one also says that the angles are like 3 times as big. So these 2 are out because we know the angles stay the same. We'll take those out. So then we have these 2 that we're going to take a look at. And it's going to be really helpful if we just draw a dilation with a scale factor of 3 here. ABC, A prime, B prime, C prime. And this test is really conceptual. I think it's really easy if we just add some numbers in there. So I'm going to say that ABC is a 2 that has side lengths of 2, 3, and 4. And since this is a dilation of 3, it's going to be 6, 9, and 12. Now I can check these 2 answers. And let's check number 1. Number 1 says that 3 times A prime, B prime. So if I did 3 times A prime, B prime, which is 6, I should get AB, which is 2. That means 18 is equal to 2. That makes no sense. All right, but let's try the next one. Number 2, B prime, C prime is equal to 3 BC. So BC in this case is 3. So I'm going to say B prime, C prime, which in our example is 9, is equal to 3 times 3. And that's 9 equals 9. And that makes sense, right? Because 3 times the preimage should give me the length of the image. So answer here is 2. This one's out. And remember, you can make your own drawings and you can make up your own numbers to help you figure out these questions. Alright, number 17. Steve drew a line segment ABCD, EFG, BF, and CF as shown below. Scaling triangle BFC is formed. Which statement will allow Steve to prove that ABCD is parallel to EFG. All right, let's take away those crappy lines. So this is actually one of the few level 4 questions. Level 4 questions about parallel lines. All right, and there's 4 types of angles we learned about, angle pairs. 1, 2, 3, and 4. We have alternate interior angles. We have alternate exterior angles. We have corresponding angles. And we have same side interior. Now, here's what would have to be true to prove that these lines are parallel. Alternate interior angles would have to be congruent. Alternate exterior angles would have to be congruent. Corresponding angles would have to be congruent. Or same side interior would have to be 180 degrees. So we're looking for one of these facts to prove that they are in fact parallel. So let's start with number 1. It says CFG, which is this angle right here, is congruent to FCB. And that's angle right here. And right off the bat, we've actually got the answer, because if you look here, these are our 2 lines. Here's our transversal, and those are congruent alternate interior angles. So that's number 1, and that relates to number 1, right? Alternate interior congruent. And you can go through the rest of these and see that none of those represent any of these angles, and so yeah, those are out. And so now we're up to number 18. Let's see if you can zoom out a little here. All right, the diagram below, CD is the image of AB after a dilation with a scale factor of K and a center of E. Which ratio is equal to the scale factor of K of this dilation? So let's do a little labeling. This is going to help us out a little later. Always label the information. It's going to help you. This is our image. This is our pre-image. Not a question about dilations, huh? So this is level 1, transformations again. Lots of questions with transformations you're seeing. And what we know is this. We know our scale factor is always equal to the distance to the image over the distance to the pre-image. And what that means is this. You want to look at this. The distance from the center of dilation to the image over the center of dilation to the pre-image. So this could be K is equal to EC over EA. And there's other ways you could state this that would be also correct. You could say ED over EB. So K could also be ED over EB. So this is image over pre-image. And you could even say CD over AB. That's also okay as answers. But if you look at your answer choices here, there's only one that works, and that is number 1. That is the image over the pre-image. And it starts at the center of dilation, goes to the line. So BA over EA, so that's BA over EA, that makes no sense. We have EA over BA, that also makes no sense. And then you have EA over EC, and obviously that's the distractor. That is the pre-image over the image, but everyone assumes that the big one is the image, which it's not. It tells you in the answer choices. All right, that's it for this lesson. I'll see you later for 19 through 24.